Alright guys, so the third question asks, using wedges and dashes, complete each drawing for 2,3-dibromobutane for the indicated stereochemistry. And so it wants RR, SS, and RS. And so the easiest way to attack these problems is trial and error. A good way of solving these problems really quickly is just knowing how to solve your configuration really quickly. But let's go ahead and just get started by drawing a wedge first. So make it easy on ourselves. The bromine is going to be the first priority. So we're going to draw a wedge instead of a dash because that would put it in our fourth priority. And then we'd have to do a fourth priority reversal. And so a wedge is just going to be a lot easier. So drawing that wedge, that's going to give us the first priority at the bromine. Here at 3, we also have a bromine. Don't know whether it's wedge or dash yet, but that will make that our second priority. And then the methyl will be our third. And lastly, the hydrogen going away is going to be our fourth priority. And so now we just want to solve the absolute configuration. We've got 1, 2, 3 is going clockwise, and so that would be R. Okay, and so now we've determined that wedges are R, so we can draw that here and draw it here. And the next thing we're going to do is we're going to do the same thing at the third position. We're going to draw a wedge, and then we're going to prioritize again, so that's going to be 1, 2, 3, and then this is also going clockwise, so that is also R. So now we've determined that using 2 wedges is going to give us an RR configuration. This information is useful because if a wedge at position 2 is R, then that means that a dash at position 2 is going to be, or going away from you, is going to be the S configuration. And the same thing goes for position 3, because if a wedge was R, then a dash is going to be the S configuration. And so we can just finish filling the rest in. And so something of importance to note is that this guy here is actually a meso compound. Usually the meso compounds are either in rings, and it's very obvious that they're meso compounds. Also, they usually have the same wedge or dash, but in this case that's a meso compound, and the reason is because this alkane is able to rotate and in essence change its configuration. And so here we had wedge dash, but if we were to rotate on right here, then our compound would look like this, and this dash, instead of going away from you, would actually go towards you. And now you'd have bromines that are both going in the same direction on a compound that has an internal plane and also 2 stereocenters. And so that's why that would actually be a meso compound. So that's something that's pretty common to show up on the assessments and can be very tricky. So just keep an eye out for that. Something else to note is that when you're using a alkane, is that if you have a wedge that is R, that next position is going to have that same configuration if you have a wedge as well. Same thing goes with where here we had SS. They both had the same configurations and we're both going away from you. That does not work with rings. Rings, let me go ahead and pull one up. Smaller rings, actually I should say, don't have that same property because they are in the cis position. So rings, and here's a drawing of that. Although you might have on this pink have the R configuration, on this next position you actually have the S configuration, and that's because unlike the alkane, which is in the trans position, small rings are in the cis position. And so just something to keep an eye out.